Chapter 6.4 Partial Fractions. In this section, we will learn partial fraction decomposition. Okay, let's say we want to add a fraction. So there are two fractions. And once you add it, what we do is we find an LCD and then write one fraction like this. And partial fraction decomposition is the opposite direction. So let's say we have an f of x. And this f of x has this is one single fraction, rational expression. So the denominator is completely factored. So let's say the denominator is completely factored. Let's say this is q of x. And the numerator is p of x. Okay, the numerator does not necessarily to be factored. So we can write f of x is p of x over q of x. And the degree of the denominator is greater than the degree of the numerator. So let's say here is the form. So f of x is one fraction. And let's say the q of x, the denominator is factored. Then from the right side of this equation, we can separate the denominator, the factors in the denominator. So we can actually decompose it. This is we can make fractions, many fractions, using factors from the denominators. So we call this partial fraction decomposition. So once we do this, we will have fractions, some fractions, several fractions. So f1 of x, f2 of x, f3 of x, and so on like this. So since each fraction has denominator, and the denominator can be a linear function, linear, or it can be quadratic function. The quadratic, factors. So linear factors, quadratic factors, and so on. So f of x can be in this format. The denominator is a linear, the base is linear, so the linear to the mth power, and the base of the denominator is quadratic. So this quadratic can be raised to some power. So m is positive integer, so m can be 1, 2, 3, and so on. And the numerator is always, the degree of the numerator is less than the base of the exponential form, the base of the factor in the denominator. So in this case, this is linear, ax plus b, so the degree is just a constant a. And for this example, the degree is x squared, because the base, the factor is x squared, which is quadratic, so the numerator is ax plus b. The degree should be less than this one. So there are four cases of the factors. Okay, here is f of x. Here is an f of x. And the denominator has three factors. And these three factors are all linears. And this non-repeated means the factor is unique. So in this case, we can, if we do this decomposition, then we will have something over x plus something over 3x plus 4 and plus something over x minus 2. We can separate each factor from the denominator. Then the numerator will be, the degree should be less than this linear, so it should be some constant a. And for the second part, this should be the constant b and constant c. So we will find A, B, C using an example later on. So let's just learn the type of the decompositions. So this is case 1, non-repeated linear factors. So f of x, the denominator of this f of x is a linear factors, and then they are not repeated. Okay, then case 2 is the repeated linear functions. Okay, repeated means, as you see this, here's the f of x. Okay, x minus 2, the factor x minus 2 is multiplied twice. That means x minus 2 is repeated twice. So x minus 2 is a repeated linear factor because x minus 2 is multiplied twice. Then we can write, when you do decomposition, we will have a fraction in a rational expression with x minus 2 and another fraction which is x minus 2 squared. So since this is repeated twice, we will have two fractions. One is the degree is 1 and the other one is degree is 2. And the third part is 2x plus 1. So we can have three fractions in this case. And the numerator is, since this is linear, the numerator is a constant. And for the second part, the numerator is another constant. Let's say it is b. And the third one is c. So when we do the decomposition of f of x, then we will have these three fractions and we can find a, b, c. Okay, case 3 is if a factor is non-linear, it can be a quadratic factor. So in this case, f of x is this. So this one has two fractions, and the first one is a quadratic, and this quadratic is not factorable. So we can have two fractions with quadratic factor and linear factor. So since for the first fractions, the denominator is quadratic, so the numerator should be linear. One degree less than the degree of the denominator. So it will be 2a plus b. We can write not 2a, ax plus b. Linear equation, linear factor. And since this is linear, we don't know the coefficient of x and we don't know the constant, so we can just use a and b. Okay, for the second part, since the denominator is linear, then the numerator is just a constant, c. So we can have this decomposition. Okay, for the last one, okay, if the quadratic factor is repeated, okay, let's say f of x is this, then we have x minus 2. So once we do the decomposition, this will be x minus 2 plus, okay, x squared plus 4 is a quadratic. So x plus 4 is multiplied twice. It occurred twice. So x squared plus 4 is a quadratic, repeated quadratic factor. So we can write fractions with x squared plus 4, one quadratic, and then since this is squared, so we can have another one, quadratic squared. All right, then the numerator is, the first one is the constant because the denominator is linear, so the numerator should be a constant. The second part is quadratic, so we can write a linear factor in the numerator, linear, so it will be bx plus c. And for the third one is also linear. The numerator should be linear because the quadratic is the denominator. So that is dx plus e. So we can find a, b, c, d, e, so that we will have a decomposition expression. So when you do if a function, the denominator is completely factored, then we can separate the denominator using each factor from the denominator. So we call it partial decomposition. So when we do the decomposition, we should have, this is the addition of fractions. So we will find the numerators. Okay, and then there's another definition that we should know, is the definition of equality of polynomials. So there are two polynomials and they are equal and they have the same degree n. Let's say P of x is an xn plus a n minus 1 times x to the n minus 1 and so on. Since P of x and R of x, these two polynomials are the same, which means the corresponding coefficients should be the same. So x to the nth power, for the x to the nth power, the coefficient of x to the nth power should be equal, and x to the n minus 1th power, then these two should be equal. For the x squared, then the coefficient of x squared should be equal, coefficient of x should be equal, and the constants should be equal. Then two polynomials are equal. So using these properties, let's try an example so that we can do a partial fraction decomposition. Okay, example 1. Find the partial fraction decomposition of this function. Okay, this function is a fraction. So, okay, in order to rewrite this function in partial fraction decomposition, we have to factor the denominator completely. Factor the denominator. Okay, so this will be, okay, this is x times x, 15 is 3 times 5, and the minus sign goes on 2, so that 3 minus 5 is negative 2. So this will be x plus 11 over x plus 3, x minus 5. Alright, so the denominator has two factors, so that we can rewrite this. So this is the case 1, isn't it? Linears. The factors are linears. So you can separate each factor in the denominator. So since there are two of them, we can write it as this: x plus 3 plus x minus 5. And then the numerator is just a constant a and b. So if we find a and b, then we are done. So in order to find a and b, let's add these two. Add these two fractions. So once we add the fractions, it will be, the LCD is x plus 3 and x minus 5. Then the numerator, the first one will be a times a minus 5, right? X minus 5. Okay, then the second fraction is x plus 3, x minus 5, and b should be multiplied by x plus 3. All right. Then let's combine these two fractions. So we have x plus 3, x minus 5. Then the numerator is a times x minus 5 plus b times x plus 3. Okay, we are getting close. Let's keep going. And then rewrite and then simplify the numerator. Ax minus 5a plus bx plus 3b over x plus 3, x minus 5. Okay, and then look at this. Okay, we have the same denominator, x plus 3 and x minus 5. By looking at this, okay, let me rewrite the denominator first. Okay, if we have here something, ax plus ax something, axb, or not axb, something. If we have something here, like a something x plus something, then when we compare this with this numerator, x plus 11, then this should be 1, and this should be 11. So which means, okay, let me rewrite this. Let me rewrite the numerators. So combine the like terms, combine the x terms. So this will be x plus a plus bx, and the constant is negative 5a plus 3b. So rewrite the numerator. So that's actually what we do is combine the like terms, so collect x terms together. Then we have the coefficient of x will be a plus b, and the constant will be negative 5a plus 3b. That's what we have. So as by comparing this, so by comparing this one, okay, this means 1x plus 11. So this one should be 1, and this one should be 11. Okay, so let me highlight this two, and highlight this two, and then compare this with this. So as we can see this, we know that a plus b should be equal to the coefficient of x, which is 1, and negative 5a plus 3b is the constant, and this constant should be equal to 11. Should be equal to 11. So we have a system of equations. So from this system of equations, we can solve for a and b. All right, so let's say this is equation 1, equation 2. Let's find AB, then we are done. Okay, why don't we multiply the first equation by negative 3. So let's get rid of b. Get rid of b. So negative 3a minus 3b is equal to negative 3. And negative 5a plus 3b is equal to 11. Add these two, then negative 8a is equal to positive 8. So a is equal to negative 1. So we found the value of a. So let's find b. So from the equation 1, since a equals negative 1, we can find b. b is plus 1 each side, so b is equal to 2. So finally, our equation is this. What we do is we just replace a and b from this. Okay, let's use this one. Okay, so this is what we want. Okay, this is the f of x, the partial fraction decomposition. Okay, this is the partial fraction decomposition, right? So a over x minus 3 plus b over x, is it x plus 3x minus 5. So this is the f of x. So we know the value of a, so that will be negative 1 over x plus 3 plus b is 2. So this is the partial fraction decomposition. Okay, what we did is simple. Using the case 1, 2, 3, or 4, factor the denominator, and once you factor the denominator, make fractions using each factor in the denominator, and then the numerator has constant values in this case. So we need to find the constant values a, b, then do the just fraction, add the fractions, and then simplify the numerator, and the numerator should be written in ax plus b format so that we can compare the coefficients. So the coefficients, corresponding coefficients should be equal. Okay, let's try another example. Okay, this is example, problem 1, example. Okay, find the partial fraction decomposition of this function. Okay, why don't you try? Pause this and then try. Okay, did you get it? All right, then let's try. Okay, the denominator, we have to factor the denominator first. So this will be, the denominator is a difference of squares, so x plus 1, x minus 1, x plus 1, x minus 1. Then since there are two linear factors, we can separate this one using x plus 1 and x minus 1. And the numerator is just constant a and constant b. Okay, look, the degree of the denominator is linear, 1. Degree is 1. So the numerator should be 1 less than the degree of the denominator. So it's a constant. The constant is just number, so I use a and b. Then let's combine these two. Okay, then this is equal to x plus 1, x minus 1, plus x plus 1, x minus 1. And what we do is multiply a by x minus 1, multiply b by x plus 1. Then the numerator will be ax minus a plus bx plus b. And the denominator is unchanged. Okay, then combine the like terms in the numerator. So coefficients are a plus bx, and then minus a plus b is the constant part. Okay, so let's compare this. So here, okay, this means 1x minus 5. So the coefficient of x, a plus b should be equal to 1, and this constant should be equal to negative 5. Okay, so we will have two equations. One is a plus b is equal to 1, and negative a plus b is equal to negative 5. So from this system of linear equations, let's find a and b. So why don't we just add these two equations? Then we have 2b is equal to negative 4. So b is equal to negative 2. So we found b. Then let's find a. So from equation 1, okay, since b is negative 2, a is equal to 3. So we found two values of a and b. So let's plug in these numbers. Okay, so our original, this is the partial fraction decomposition. And then we will replace this a and b. So the answer will be, okay, let me write it over here. So f of x will be, a is 3. Okay, let me write it here. This is a over x plus 1 okay, this is a over x plus 1 plus b over x minus 1. So our answer will be a is 3. So 3 over x plus 1, and then b is negative 2, so why don't we put minus 2 over x minus 1. So this will be the answer. This is the partial fraction decomposition of f of x. Example 2, find the partial fraction decomposition of this function. Okay, the denominator is already factored, and the denominator is actually x squared x or x cubed. So the denominator, the degree of the denominator is greater than the degree of the numerator. So this one is okay. And then this is x minus 1 is, isn't it? Is x minus 1 or repeated linear factor, right? Repeated linear factor. So from this one we can have 3 fractions. So let me write it here below. So f of x will be something like this. Okay, something over x, because we have one factor x and x minus 1, and x minus 1 is repeated twice, so we have x minus 1, and another fraction will have x minus 1 squared. Alright, and the denominator is linear, so we will have constant numerator here, and a constant numerator. Okay, so let's find ABC. Then from this, okay, the denominator is, the LCD is x minus 1 squared is the LCD. So we gotta multiply the numerator a by x minus 1 squared. Same thing. For the second fraction, b should be multiplied by this time x. Okay, this time b should be multiplied by x and x minus 1. And for the last one, x times x minus 1 squared. So multiply c by the missing factor x. And then what we do is add the numerator. So denominator is x times x minus 1 squared. All right, let's add it. Okay, before we add, let's distribute first. Okay, a times x squared minus 2x plus 1. Okay, b x squared minus bx plus cx. Okay, keep going. And this will be a x squared minus 2ax plus a plus bx squared minus bx plus cx divided by x times x minus 1 squared. Then this is equal to, and then let's combine the like terms. So x squared, the coefficient of x squared will be a plus b x squared. Okay, coefficient of x will be negative 2a minus b x. And we have another x. Okay, we have another x, which is c. Plus cx. And the constant is only a over x times x minus 1 squared. Okay, let's compare this with the original function. Okay, the original function is this. X squared plus 2x plus 7. X squared plus 2x plus 7 over x times x minus 1 squared. So from this is 1. So this the coefficient of x squared should be equal to 1, and the coefficient of x should be equal to 2, and the coefficient should be equal to 7. So let's write an equation, system of equations. So a plus b is equal to 1 and negative 2a minus b plus c is equal to 2, and finally a is equal to 7. All right, we already found a. Already a is given. Let's say this is equation 1, 2, 3. Already a is 7, so let's find b. Because from the equation 1, let's find b. A is 7, so 7 plus b is equal to 1. So b is equal to negative 6. Okay, let's find c from equation 2. So a is 7, so negative 2 times 7. B is negative 6. Then negative 14 plus 6 plus c is equal to 2. Then negative 8 plus c is equal to 2. So c is equal to 10. All right, we found b and c, and a is given. So the answer will be, okay, from here, not from here, sorry. So from the original, from here. Okay, that's the f of x. So let me write down f of x. We know that f of x is a over x plus b over x minus 1 plus c over x minus 1 squared. And then we found the x values. So the answer will be a is 7, so 7 over x, plus b is negative 6. So why don't we use minus 6 over x minus 1. And finally c is 10, so 10 over x minus 1 squared. So this is the partial fraction decomposition of f of x. Okay, so what we do is factor the denominator and then separate each factor in the denominator. If a factor is repeated, it has power 2 or 3, then we will have multiple fractions using the same factor. And then the numerator is always the numerator is 1 degree less than the denominator. Okay, 1 degree less than the denominator. And the denominator of, the factor of the denominator is all linear. Okay, this is actually linear. Okay, x minus 1 is linear. So the numerator is a constant. Okay, let's try another example. Okay, let's find the partial fraction decomposition of this function. Okay, the denominator is factored and x minus 3 is repeated. So we can separate the denominator, each factor in the denominator. So it will be x something over x plus something over x minus 3. And x minus 3 is repeated twice. We will write down one more x minus 3, which is squared. So if this is cubed, then we will have another one, x minus 3 cubed. But this is square, so we will write up to square. All right, the numerator is all constant because x is linear, so write down constant a. X minus 3 is linear, so write down the constant b. And x minus 3 is linear, not x minus 3 squared. What we're looking for is x minus 3, the base. So the base is linear, so the numerator is a constant. All right, then the next step is add these three fractions. So the LCD is x times x minus 3 squared. That's the LCD. So multiply a by x minus 3 squared. And for the second fraction, x times x minus 3, so multiply b by x. And then for the x times x minus x times, wait a minute, x times x minus 3. And for the third fraction, x times x minus 3 squared, so multiply c by x. Okay, then this is equal to, let me write on the right hand side. So denominator is x times x minus 3 squared. And then, okay, combine the numerators. So the numerator is 8 times x squared minus 6x plus 9 plus bx squared minus 3bx plus cx. Okay, then this is equal to, okay, distribute, so ax squared minus 6ax plus 9a plus bx squared minus 3bx plus cx over x times x minus 3 squared. So this is equal to now, okay, combine the like terms in the numerator. The coefficient of x squared is a plus b x squared. Okay, let me write this in the next line. Next line is better. So the numerator is a plus b x squared. And the coefficient of x is negative 6a minus 3b plus c. And the constant is 9a. And denominator is unchanged. All right, so we just simplified the numerator. And then let's compare the coefficient of the numerator. Okay, so let's go back to the original. Okay, this is the original one, right? Original one. So negative 7x plus 27. This should be equal to negative 7x plus 27 over x times x minus 3 squared. Is the numerator correct? Okay, negative 7x plus 27. All right, so the coefficient of, there's no x squared. No x squared means 0 times x squared, right? 0 times x squared. So the coefficient of x squared should be 0. And the coefficient of x is negative 7. So this part should be negative 7. And the constant should be 27. Okay, so let's write a system of 3 equations. So a plus b should be equal to 0. And then negative 6a minus 3b plus c should be equal to negative 7. And 9a is equal to 27. So we have equation 1, equation 2, equation 3. So from the equation 3, a is equal to, okay, 9a is equal to 27. So a is equal to 3. We found a. Then from the equation 1, a plus b equals 0. A is 3. So b is equal to negative 3. And let's find c. So from equation 2 is negative 6a minus 3b plus c equals negative 7. And a is 3. So negative 6 times 3 minus 3 times b is negative 3 plus c equals negative 7. Negative 18 plus 9 plus c equals negative 7. Negative 9 plus c equals negative 7. So c equals now plus 9 each side, and c is equal to 2. So we found all the values of a, b, c. So let's go back to the original. Okay, in this case, this one, right? So let me write f of x, a, b, c. So here, f of x is equal to a over x plus b over x minus 3, isn't it? C over x minus 3 squared. So the answer will be a is 3, so 3 over x. B is negative 3, so it will be minus 3 over x minus 3. And then c is 2, so 2 over x minus 3 squared. So this is the partial fraction decomposition. Okay, example 3, find the partial fraction composition of this function. Now the denominator of f of x has two factors. One is linear, the other one is quadratic factor. So we have two factors, so we can separate this function into two fractions. So something over x minus 2 plus the second factor is quadratic. All right, and then the first fraction has the denominator of the first fraction is linear, so we must have a constant in the numerator, and the denominator of the second fraction is quadratic. This is quadratic, so the numerator should be a linear, so 1 degree less than the quadratic, which is linear, so it will be bx plus c. Because this is squared, the denominator is squared, so the numerator is 1 degree less than the denominator. So it should be just a linear equation, linear factor. So bx plus c. All right, then let's combine this. Okay, the LCD is x minus 2, x squared plus 7. And this is x minus 2, x squared plus 7. So we will multiply a by the missing factor x squared plus 7. And for the second fraction, bx plus c will be multiplied by the missing factor, which is x minus 2. All right, then the denominator is still same. The numerator is, let's add the numerator. Okay, before we add it, let's distribute. So a x squared plus 7a plus, use the FOIL method for the second, the numerator in the second fraction. Bx squared minus 2bx plus cx, and then minus 2c. All right. Then combine the like terms. So the coefficient of x squared is a plus b x squared. And the coefficient of a is 7. Coefficient of x. Okay, coefficient of x is negative 2b plus c x. And the constants are 7a and minus 2c. Okay. So we just rearranged the numerator. So we wrote the numerator in quadratic standard form. So this one should be equal to, okay, let's go back to the original. Should be equal to 3x plus 16. 3x plus 16. And denominator is x minus 2, x squared plus 7. So from this, the coefficient of x squared, this means x squared, the coefficient of x squared is 0. So a plus b should be equal to 0. And the coefficient of x should be equal to 3. And the constant part should be equal to 16. The numerator should be equal. So that means the corresponding coefficients should be equal. Okay, so we have system of three equations. A plus b is equal to 0. Then negative 2b plus c is equal to 3. And then 7a minus 2c is equal to 16. Okay, let's find the values of a, b, c. All right, so from this, okay, why don't we eliminate. Okay, so look at this. We have BC, AC, AB. So from this, why don't we eliminate 2B? Okay, so AB, BC. Okay, let's eliminate this one using the first equation. So I will multiply the first equation by negative 7 and add it to the third equation. Okay. So negative 7a, multiply the first equation by negative 7. Negative 7b is equal to 0. And the third equation, 7a minus 2c is equal to 16. So once we add these two, cancel out a, then negative 7b minus 2c is equal to 16. Let's say this is the equation 4. Then from the equation 3 and 4, let's compare equation 2 and 4. Equation 2 and 4. Equation 2 and 4. Let's check equation 2 and 4. Okay, 2 is negative 2b plus c is equal to 3. And 4 is negative 7b minus 2c is equal to 16. Then from this, let's get rid of c. So let's say this is 5, 6. So why don't we multiply equation 5 by 2 and add it to the sixth equation. So there will be negative 4b plus 2c is equal to 6. And 6 is negative 7b minus 2c is equal to 16. Once we add it, this will be minus 11b is equal to 10. Wait a minute, we should not have these numbers. Okay, let me check this one. Okay, I found the error. Okay, when we add these two, this should be not negative 2, negative 9, right? Negative 9. So we have to get rid of this, negative 9. Okay, so that is not right. So negative 9. This is negative 9c. Then equation 4 is negative 7b minus 9c is equal to 16. So let's multiply the fifth equation by 9 and then add it to the sixth equation. Okay, so negative 18b plus 9c equals 27. Negative 7b minus 9c is equal to 16. Add these two equations. Negative 25b equals 43. Still, we don't have the number. The number is not right. Okay, this is negative 2. Oh my God. Negative 2, because the first one is negative 7b. This is 2c. So this got to be negative 2. I'm doing incorrectly. Why I keep making mistakes? Okay, so the coefficients are different. So actually this is negative 7b minus 2c, right? Minus 2c. So the second equation is negative 2b plus c equals 3, and equation 4 is negative 2b minus 2c is equal to 16. So we will multiply the fifth equation by 2, multiply by 2 so that we can get rid of c. Then that will minus 4b plus 2c is equal to 6, multiplied by 2. Okay, then the fourth equation is unchanged. Then once we add these two, negative 11b is equal to 22. So b is equal to negative 2. Okay, we found the b value. Okay, we found the b value. Then starting from, let's use the first equation to find a. Let's find the first equation. A plus b is equal to 0. B is negative 2. So a equals 2. So we found the a value. And then let's find the c. Okay, from the third equation or second equation. Okay, let's use the second equation. Okay, the second equation is negative 2b plus c. So negative 2 times b is negative 2 plus c is equal to 3. Then 4 plus c is equal to 3. So c is equal to negative 1. So we found the values of a, b, c. So let's go back to the front. And we have this equation. F of x is sum of these two. So let's write this and then replace a, b, c. So denominator is x minus 2, x squared plus 7. So here f of x is equal to a over x minus 2 plus bx plus c over, okay, so x minus 2, and then the second part is the x squared, the second factor is x squared plus 7. So finally a is 2, so 2 over x minus 2, and b is negative 2, so you can write it negative 2x, c is negative 1 over x squared plus 7. So this is the partial fraction decomposition of the function f of x. Okay, let's find the partial fraction decomposition of this function. Then f of x can be written as something over, okay, a over x minus 5. And the second fraction is x squared plus 3. So the numerator should be a linear, so bx plus c. Then this is equal to x minus 5 times x squared plus 3. And a should be multiplied by x squared plus 3. And the second part is x minus 5 times x squared plus 3. And then bx plus c is multiplied by x minus 5. Okay, then the numerator is ax squared plus 3a plus bx squared minus 5bx plus cx minus 5c. X minus 5, x squared plus 3, unchanged. Okay, then combine the numerator. Then the x squared, the coefficient of x squared is a plus b. And the coefficient of x is negative 5b plus c. And the constant is 3a minus 5c. All right, then let's rewrite this. So this one should be equal to original function, 3x squared plus 6x minus 21 over x minus 5, x squared plus 3. So the coefficient of x squared should be equal to 3. The coefficient of x is equal to 6. And the constant has to be equal to negative 21. Okay, so the system of three equations is a plus b equals 0. And then negative 5b plus c is equal to 6. And then 3a minus 5c is equal to negative 21. A plus b is equal to, a plus b is equal to 3. Okay, so this is equation 1, equation 2, equation 3. All right, then let's get rid of 3a from the third equation using the first equation. So I will multiply the first equation by negative 3 and then add it to the third equation. So 3a plus negative 3a minus 3b is equals to negative 9. 3a minus 5c is equal to negative 21. Add it. Then cancel out a term. Then we get negative 3b minus 5c equals negative 21. Okay, let's say this is equation 4. Then let's use equation 2 and 4 because they have variables b and c. So okay, let me write it here, 2 and 4. Okay, 2 is negative 5b plus c. And 4 is negative 3b minus 5c is equal to negative 1. So from this, let's multiply it. Let's say this is equation 2 and this is equation 4. So why don't we multiply get rid of c, variable c, so multiply the second equation by 5 and add it to the fourth equation 4. Then multiply by 5, so negative 25b plus 5c is equal to 30. And negative 3b minus 5c equals negative 21. Add it. Negative 28b is equal to, that is 20. Oh, what is, something is wrong again. Let me check. Okay, I found the error. The error comes from here. This one, negative 9 minus 21 is negative 30. That's negative 30. Okay, so this should be negative 30 and negative 30, negative 30. So once we add these two, then this becomes 0. So finally, b is equal to 0. Okay, we got the b value. Then let's use, okay, from the equation 1, a plus b is equal to 0. And b is 0, so since b equals 0, a is equal to 0. Okay, then let's find c. Okay, let's use equation 2 to find c. Okay, 2 is negative 5b plus c is equal to 6. And since b is 0, oh, wait a minute. Why do I keep writing this 0? Okay, here, this is not 0. A plus b, what is a plus b? A plus b is 3. A plus b is 3, right? 3. So a is equal to 3. Okay, now from here, b is 0. Then c is equal to 6. So we found ABC. So let me write the function f of x. We found ABC. So the function f of x is equal to a over, what is the first factor? X minus 5 plus bx plus c over, the second factor is x squared plus 3, x squared plus 3. Okay, so basically we already found ABC, so we can replace ABC from here. So, okay, a is 3, so we have 3 over x minus 5 plus b is 0, so 0x is 0, and then c is 6, so we have only 6. So this is the partial fraction decomposition of the function. Okay, example 4, find the partial function decomposition of the function, and the denominator of this function is a quadratic, and the quadratic is repeated twice. Alright, so since this is squared, the denominator is squared, there we will have two fractions. Okay, one is x squared plus x plus 1, and the other one is x squared plus x plus 1 squared. And the base, the quadratic x squared plus x plus 1 is not factorable. So we know that the denominator is completely factored. So since the denominator, the factor in the denominator is a quadratic, the numerator is a linear. So we can write it ax plus b, and for the second fraction is cx plus d. Okay, the factor in the denominator is quadratic, so the numerator has polynomial whose degree is 1 less than the degree of the factor in the denominator. Alright, then from this we know that, okay, let me write in the next line. Okay, the LCD is x squared plus x plus 1 squared. This is the LCD. So we have to multiply ax plus b by the missing factor in the denominator in the LCD, x squared plus 1, x plus 1. Okay, the second part is unchanged. So we can combine these two. Now it's gonna be a lot of, the numerator will be very long. So let's write the numerator. Okay, distribute. So ax can multiply like this. We will distribute. So there will be ax cubed plus ax squared plus ax, and then multiply b. So plus bx squared plus bx plus c, and finally cx plus d, and the denominator is x squared plus x plus 1 squared. Alright, and then let's combine the like terms in the numerator. So ax squared, x cubed, there's only one term, x cubed term, and combine the x squared. So the coefficients of x squared is a, b, that's it, and the coefficient of x is a plus b plus cx, and the constant is c and d. C plus d is the constant. All right, so this equation should be equal to, what's the original function? Okay, 4x cubed plus 5x squared, this one. This is the original function, the numerator in the original function. 4x cubed, 5x squared, plus 7x minus 1 over x squared plus x plus 1 squared. All right, so using this one, the coefficient of x cubed, which is a, should be equal to 4. And then the coefficient of x squared, which is a plus b, is equal to 5. And the coefficient of x, which is a plus b plus c, should be equal to 7. And the constant should be equal to negative 1. The constant is b. Is the constant b and d? Okay, let me check on this one. I think something's wrong. Yes, I found the error. So okay, b times 1 is b times 1. Okay, b times 1 is b, not c. This is not right. So that should be b. This should be b. Okay, this one has to be b, right? B. Okay, so let's write a system of equations, 4 equations in this case. A is equal to 4, and then a plus b is equal to 5, and then a plus b plus c should be equal to 7, and then b plus d is equal to negative 1. So we have 4 equations, 1, 2, 3, 4. So from the first equation, we already found the value a. Okay, a is equal to 4. Then from the second equation, we know that a is 4. So b is equal to 1. Okay, from the third equation, a plus b plus c is equal to 7, and a is 4, b equals 1, then 5 plus c is equal to 7, so c is equal to 2. All right, and then equation from the equation 3, equation 4. From the equation 4, b plus d is equal to negative 1. b is 1, so d equals negative 2. All right, a is 4, and we found all the values of a, b, c, and d. So let's plug in these numbers. So, okay, this is f of x. Partial function decomposition. So let me write it here. Let me write it at the bottom so that we can write the answer. F of x is equal to ax plus b over x squared plus x plus 1. And the second part is cx plus d over x squared plus x plus 1 squared. And then replace a, b, c, and d. Okay, a is equal to 4. So this will be 4 over 4x. So that is 4x, ax plus b. b is equal to 1. So 4x plus 1 over x squared plus x plus 1. and C and D. Okay, C is 2, so 2x minus 2 over x squared plus x plus 1 squared. So this is the partial fraction decomposition. Okay, example 5. Okay, let's find the partial fraction decomposition of this function. And this function has the degree of the numerator. The degree of the numerator is greater than the degree of the denominator. So what we do is we will use the long division method and then rewrite the function. So let's use the long division so that we can reduce the degree. Okay, then the first part is x, so this will be x cubed minus 7x squared, and then subtract, then this will be 3x squared minus 19x, and the second part is plus 3, then 3x squared minus 21x, subtract, then plus 21, so 2x minus 35. So 2x minus 35 is the remainder, and then x plus 3 is the quotient. Okay, so this is the quotient, and this is the remainder, and this is the divisor. So we can rewrite the function. So f of x, okay, so this f of x can be rewritten like this. Okay, the quotient is x plus 3, so write down x plus 3, and we have a fraction. The remainder is 2x minus 35, and the denominator is x squared minus 7x. So this is the new f of x. So by using the long division method, we obtained this expression. So from this, why don't we do the partial fraction decomposition for this function? Let's say that is g of x. Then from this, let's do the partial decomposition. Then the numerator is still same. The denominator, we have to factor the denominator. Then there will be x times x minus 7. So we can separate this x and x minus 7. Since the factor in the denominator is linear, the numerator is constant, so a and b. Then this indicates that the LCD is x times x minus 7, so multiply a by x minus 7. And the second fraction is multiply b by x. Then this is equal to, okay, ax minus 7a plus bx. Denominator is this. And then combine the like terms in the numerator. So the coefficient of x is a plus b. And then constant is negative 7a. So if we compare this with the original one, the original function is, okay, let me use different color. So this is equal to 2x minus 35 over x times x minus 7. So a plus b, the coefficient of x should be equal to 2, and the constant is equal to negative 35. So this will give us two equations, system of two equations. A plus b is equal to 2, and negative 7a is equal to negative 35. So from this equation 2, a is equal to 5. And then from the equation 1, since a is equal to 5, b equals -3. All right. So the original, this is so p of x, so g of x is, what's g of x? So, okay, here. So this is the g of x. So x and x minus 7. So g of x is a over x minus, just x, right? Just x. b over x minus 7. Okay, a over x plus b over x minus 7. And then a is 5. X over x plus b is -3. So -3 over x minus 7. So that is g of x. Then what is f of x? The f of x is, okay, if we go up here, okay, this is the f of x. X plus 3. So you can write it x plus 3 and then g of x. And this is the g of x. So 5 over x minus 3 over x minus 7. So this is the partial fraction decomposition of a function whose degree of the numerator is larger than the degree of the denominator. So this is what we did. Since the degree of the numerator 3 is greater than the degree of the denominator with 2, so what we do is use the long division method to divide. So once we divide it, it becomes like this. X plus 3 plus some fraction. And from this fraction, we can do a partial fraction decomposition. So let's say this is the g of x. And from this g of x, do the partial fraction decomposition. So we have two fractions, a over x plus b over x plus 7. So once we find a and b, just plug it in here. And this one goes to the g of x. So finally, we will have f of x. Okay, f of x is this one.